So this is data design challenges for enterprise IoT applications. I decided to drop the semantic ontology stuff in the interest of time. If anybody's here specifically about semantic ontologies, then you can throw tomatoes or we can talk in the hall afterward. So my name is Zach. I work for GE Digital. I'm a data viz guy, an interaction designer, and a product person. And I'm going to talk about basically what we're working on in abstracted terms, so I don't violate any agreements. But we're working on Internet of Things applications, and we build stuff like jet engines, trains. The technical term would be locomotives and not choo-choos, as sometimes we call them. And other things of that nature. We call it the Internet of Big Things. So what I'm going to talk about today is how designers approach data and the need to approach data intelligently when we are designing data visualization applications. So this presentation is geared toward designers. And like a lot of designers, I came from an arts background, and the thought of programming and math strikes fear into my heart to this day. So I think really a better term for this is probably go home data, you're drunk, because that's really how a lot of designers feel about data. It's something that's sort of scary and foreign. And go figure, a lot of the data that we work with it's quantitative, it's mathematically driven, it's programmatically created, and it's basically as far from design as you could imagine. So when you get past that, though, I think that designing with data in mind, and what I'm going to start calling data-first design, not a term that I've coined, by the way, it'll put design in a whole new light. And my hope is that this presentation will get rid of some of the fear, but judging by the looks of you guys, I don't think any of you are especially afraid of data. You don't look like a design audience. Raise your hand if you're a designer. Anybody a designer in here? Okay, all right, thank you. I'll take it. So we're going to go from go home data, you're drunk, to data first design. And to be clear, I don't mean that we should all become data scientists or statisticians, which probably most of you already are. Data first design to me is not about data above everything else. It's about prioritizing data exploration the same way that we would prioritize, say, user research or usability testing. After all, we do them for the same reason, and that's to ultimately make a better product. So what this presentation is not, it's not a Kai paper. Kai was last week. I'm going to reference some research, but all the stuff that I'm going to talk about in here is really, anecdotal, and it's my own experience on it. So, also, these are challenges that are the subject of a lot of ongoing visualization research. So there's really no silver bullet. I'm merely suggesting that doing data exploration as a designer is something that's valuable, but it won't solve all of our problems in making, complex data-driven products. So what am I going to talk about? I'm going to talk about a quick working definition of what a designer is and what data is. Then I'm going to show a little bit of research about how designers have traditionally approached data. And then I'm going to lay out some examples from my own experience, and hopefully those will suggest some solutions along the way. So who are you? As we've established, only one of you is a designer. So this is a presentation about designers. So I don't have any hard and fast rule about what you are, but you're probably skewed more toward a designer at an agency, or excuse me, at an enterprise rather than an agency. And you're probably working on applications for professional users. You're not working on consumer-facing applications, and probably there's not a lot of mobile in your life either, at least there's not in mine. But our challenge, and I'm speaking of myself here, is that we're working with data that's kind of out of our league. We're not doing infographics here. So with that in mind, what is an infographic in this respect? I think that this has been covered pretty well by a lot of other speakers in a lot of other areas. But I think that there's a big difference between visualization and infographics. And infographics are going to be very much data-driven. They're going to be highly abstracted. The data is not going to be represented in nearly the complexity and level of detail as it would be in a visualization. There's really no explicit data exploration step. There's little data wrangling. And again, these aren't hard and fast. These are just kind of what I've seen in my experience. Finally, it's made with tools like Illustrator and other design tools as opposed to being programmatically encoded. And the flip side of that is that it's actually going to be manually encoded. So some designer is going to go in there and actually make dots in the application to show where data will be. So in contrast, a data visualization is going to be far more data-driven. It's not going to be abstracted. You're going to see much higher level of granularity with the data. It's going to be made with tools like, at the very least, Excel, but probably something like MATLAB or R or other packages like that. The tool is going to do the data encoding, so nobody's going to hand encode data. It could be highly dimensional data. It could be lots and lots of data. And there could be static or streaming data. And there's usually an explicit data wrangling step that's involved as well. And then there's going to be, it could be relational data. It could be graph databases. It could be unstructured or structured, et cetera. Essentially, it could be almost anything. I'm just talking here more about the data that I've encountered in my day-to-day work. So, put simply, the difference is on where the emphasis lies. So does it focus on aesthetics or does it focus on analysis? And of course, not mutually exclusive. I think good design should do both. But in general, the motivations for an infographic are, there's going to be some narrative aspect to it. It's going to tell a story. It's going to be interested in persuasion, entertainment, potentially marketing, another form of persuasion. Whereas data visualization is more geared toward analysis, identification, experimentation, or externalizing a concept that's highly abstract and complex. For example, a cost function in logistic regression, which is what this visualization is. So just to be clear, data visualization is not a single monolithic subject. There's lots of different subdisciplines. And I'm not suggesting that the compelling aspects of infographics should be left out of data visualization. They all need to tell stories. They all need to persuade. It's just the call to action that comes out of that is probably more around actionable data rather than a purchase decision, for example. So I bring this up to highlight the fact that most designers, the skill set that most designers have is not really sufficient for doing what's on the right. So that's the designers a little bit, and that's the data a little bit, or excuse me, that's the, let's talk about the data a little bit. So I've mentioned it could be structured or unstructured. It could be time series, which is where I've spent a lot of my time. It could also be graph, which is another place I've spent a lot of time. If it's time series, it might not be of constant data density or scale. It may or may not have any data, metadata with it. It may or may not have unique names. Units of measure might be different. There could be really complex architectures that are kind of a dependency to be able to surface it in a UI at all or run any kind of analytic on it. Again, it could be highly dimensional or it could be big, tall, or fast. So accessibility, and honestly, this is the biggest challenge that I've faced in working with any kind of data. Being able to surface it at all is, there's a big dependency on getting it all into one unified, integrated place. So there's huge demand for systems integrators in this space. But you can have workarounds for design, but if you don't have accessible data, there's no real workaround for that. So to that point, our biggest challenge is just getting it all in one place, having it accessible, having it integrated, having it cleaned. It's a non-trivial tasks, and each one of these steps presents a point of failure, a potential point of failure in any visualization application or analytic, for that matter. So, data accessibility, huge issue. So I want to pivot a little bit to the designers here and talk a little bit about how designers have approached data traditionally. This is a really great paper about how designers work from University of Utah that came out maybe 4 or 5 years ago now. They determined that a lot of designers approach data based on their skill set and the tools that they're comfortable with. So the tools that you're comfortable with, if you're comfortable with the tools on the left there, things like Illustrator, Hype, various design tools, you're probably going to be less familiar with the ones on the right. If you're a pro with both of these, then you're a purple spotted unicorn, as someone once told me. I don't know anybody that can do MATLAB as well as they can do Sketch, for example, and knows both of those well. So big divide in terms of skill sets there. Another thing that they came up with was that designers' inferences about data are they're occasionally divorced from the actual data. In other words, designers will look at the problem and then start designing based on their assumption of what the problem is, rather than doing any kind of formative data exploration step, which is what I'm calling data-first design. So finally, they also determined that a lot of how comfortable you are is correlated with, the amount of data exploration you do is correlated with how comfortable you are with data in the first place. So going back to what I opened with, a lot of designers are scared shitless of data. So there's not a lot of data exploration because they just don't really know how to approach it. And that's not universally true, but it's occasionally true. Unfortunately, this all starts falling apart when you start looking at big, complicated, and abstract data. So I would contend that you reach this point pretty quickly, and as the amount of data that we work with grows, that point is going to become sooner and sooner in the design process. So when you start working with this stuff, you have to really, if it's for placement only in design terms where you're roughing something in, you're mocking something up, and you can't even do that without having some understanding of the data anymore. So there's a point at which you can't actually do this without having some visualization package, or at least being able to understand the scale of the data you're talking about. So I'm going to switch to tactics here. I'm going to make things a little bit more concrete with some examples that have come out of my work. So let's say that we're talking about a tool for an analyst. The use case is monitoring assets to analyze and ultimately prevent failures. And this is a real use case that we face, pretty much our overarching use case at GE Digital. So she's monitoring a fleet of assets. One of GE's verticals is jet engines. So let's say she's working on jet engines, and she needs to understand not only why an asset has failed, but also, and more importantly, to prevent it from failing in the first place, ultimately. So how does she do this? Well, the engine has sensors on it, like a lot of instrumented IoT objects. And those sensors collect data from the engine. So in this case, for example, your body temperature, 98.6 Fahrenheit. There's a thing called exhaust gas temperature, which is a pretty good corollary. So things like that, RPMs, altitude, et cetera. So the analyst needs to compare these variables and identify the critical X's. This is kind of a common pathway for analysts to do this. They're going to lay out a whole bunch of different variables and then go through them and use human pre-attentive cognition to say, oh, hey, I instantly recognize that in quadrant 1B or whatever, there's a problem, there's an issue there. So then they're going to start drilling into that to dig down and start plotting out time series and independent singular variables rather than looking at these matrices. So she's going to start with a chart like this, and she's going to compare those X's. She's going to scan it. And let's say that we're just going to deal with a single asset here, because in the real world, they're going to be comparing many, many assets, fleets of jet engines, 40, 50,000, each of which have 400 to 800 sensors on them, and then they're going to generate time series based on that. So let's say that we're coming back down to just one asset. And the takeaway is that without first examining and understanding the data, it would be really easy to think that just comparing the time series for these is pretty trivial. So let's say that these are the variables that she wants to compare here. So analysts might know that this event occurred for under a certain set of operating conditions. And let's say that the asset, the jet engine that she's looking at, is a 20-year-old engine. So it's kind of old. It's been pushed pretty hard. So just like if you drive your car really, really hard and you redline those RPMs a lot, it's going to impact the way it performs in your life on it. So it's been abused. Let's say it's also been flown in a place like Dubai, where there's sandstorms, there's hot and harsh conditions, it's 100 degrees Fahrenheit or more throughout a large part of the year. So she's going to be able to take that kind of environmental data about the asset, and then that's one thing she's going to plot, but she's also going to look at things like airspeed, exhaust gas temperature, altitude, and all these things, and she's going to line these things up in time to try and examine where, basically she's trying to narrow down what caused this. So this is FMEA, it's failure mode analysis, basically of why an engine failed. So she's also going to know what a healthy engine of this model and year and under those conditions would look like. And she's going to compare those two types of data. So even if we have one asset that we've narrowed this down to, it's entirely likely that she's going to be comparing it to either data for that asset in the historical data or abstracted data for that class of asset. So your Honda Civic, how your Honda Civic would compare to the exact same conditions, everybody else's Honda Civic under those conditions, if that makes sense. So at the end of her investigation, she's going to want to use that data to forecast failure in other similar assets under similar conditions. So let's say that she wants to plot these 5 pieces of data. So if we're going to take a design first approach, we might start with something like this. So we've got X along, the x-axis would be time, the y-axis would then be the scales for the different variables. And we need to have we've got 5 different variables there. One's got wind speed, might be in miles per hour, kilometers per hour. Stop doing that. Temperature is going to be Fahrenheit or centigrade. Oil pressure might be pounds or kilograms per inch. altitude feet or meters, airspeed again could be knots, and then RPMs is RPMs. So we've got a bunch of different kinds of data there, hence the need for a bunch of different y-axes. So we might experiment with our design and do something like this, where we start stacking them up, because pretty quickly you get, if you're looking at something like this, it gets ugly real fast. Ditto with this isn't going to scale very well. You got 4 there, we didn't manage to get 5 in this view. And then if you want to get fancy, you might do something like this, where you're obfuscating data based on like interaction, like you're hovering and showing a y-axis based on what you hover, and everything else is grayed out. You might be able to do something like this, where you're packing lots of stuff into the view, but eventually you're going to reach a point at which the data is too dense and overplotted to really be usable. So the problem is clear that none of these design-first solutions really accommodate the actual use case. Remember that we've simplified this down to looking at a single asset. We're not looking at fleets of assets. So this is there's going to be a huge scalability problem here. And I know the last presenters mentioned that as well. And data scaling should come as no surprise at a conference like this. It's going to be a big problem. So nail it before you scale it. And this also opens up a whole debate on the lean process and MVPs, which I'm going to just sidestep. But we need to nail down our use case before we start designing and looking at any kind of interaction features or things like that. And then one other caveat, these, like I said, these are ongoing problems. So there's no silver bullet from data visualization community about how to do this. But let's contrast this with a data-first approach. So if we look at the data first, we might look at things like scale. We'd look at the units of measure, and we'd know that by looking at those units of measure, we'd see that they're going to be very different. We've got, like I mentioned, we've got RPMs, we've got temperature, we've got speed in different units of measure, things like that. Take temperature, for example. It could be centigrade, Fahrenheit, Rankine, Kelvin. All of these are going to have different scales. And also, this could be coming from multiple sensors. So you might have 10 or 15 or 100 different thermometers in the engine. And the data that you're actually plotting might look like, might be averaged and normalized down to a point where you're losing anomalies and outliers from the data. So things to know about beforehand. Secondly, you'd see that data is going to behave a little differently in the wild. So you need to run a use case like your user is going to do it. So the other thing is, for example, how many times, what's your sampling rate of the data? For example, if you're looking at something like data that's sampled over the course of an 8-hour flight, maybe there's things that are sampled 5 times, like once, like throttle changes. For example, if the plane climbs or declines in altitude, that might trigger a data point. So there might be 5 of those, but something like exhaust gas temperature might be sampled 5 times a second. So you've got 180,000 data points that you're comparing to 5. So you're going to have to do some kind of time warping to compare those things. Otherwise, if you end up having a Euclidean, straight line comparison, it's not going to work, because you're not going to be able to line those things up. So again, very non-trivial challenges for visualizing this data. So out of this come a few assertions. Understand the use case. Minimally viable is fine, but again, nail it before you scale it. Understand the data. Look very closely at it. Streaming, static, time series, graph, etc. Units of measure, scale, ontologies that are underlying it, what the relationships are. Understand the architecture. Is it cloud or on-premises, or is it distributed or unified? Will the architecture support the necessary data performance? Because things that I've run into are things like search. Can you, do you have the throughput to support search of massive amounts of data? Finally, don't be afraid to do research and know the state of the art, and bring in experts if you need to. So, thanks for not running screaming. I appreciate your interest. And just to sum up, I think that we need to do more data first in our design, and it's going to lead to better products. So thank you very much.
There's a bit of time for any questions.
Sir?
Actually, I come from a technical background. I love data-centric design. However, it's actually harder for me to think you only focus on data itself. When you're interested in data, I think you will have something that you want to do in mind. can actually drive what you are looking for from the data. And the last slide you lay out, I think those are other dimensions of a design task you must consider. You have to consider what's the task you want to perform, as well as the data available to you, their characteristic, and what's the process, and so on. But still, you want to deliver the value add to the people who's going to use it. And that's still going to be, I think, is more user-centric.
Yeah, I agree. So just to restate your point, it sounds like you're emphasizing the need to solve legitimate user problems and to have a kind of a product-focused approach to this. I couldn't agree more. I think that's something that gets lost very regularly, and at least where I work, people tend to get tunnel vision on their little part of the product, and because they're experts, and that's what they focus on. So I think we're at time. Thank you very much.